With steadily rising temperatures, it's a good time to talk about how engineers use evaporative cooling to help you maintain your chill. Evaporative cooling uses water physics to boost heat transfer. When water evaporates, it changes state from liquid to gas. The energy needed for that state change comes from the water itself, draining off some of the thermal energy present and lowering the temperature. An easy way to show this is with two thermometers. Wrap a wet paper towel around one thermometer and put both thermometers in water and let the temperature equalize. After that, pull both out, check the temperature is roughly the same, and then dry off the bare bulb. The dry bulb thermometer shows the air temperature at 27 degrees Celsius. Meanwhile, evaporation of the wet bulb has cooled that one to just above 20 degrees Celsius, a full 6 degrees cooler. A similar example of evaporative cooling is how cold the air feels when you first step out of a pool or a shower, even on a warm day. Engineers use that cooling effect from evaporation for anything from building air conditioning to running nuclear power plants, getting that extra few degrees cooling where we need it most. Natural evaporative cooling is also an excellent climate change mitigation strategy for our cities, where expanding the urban tree canopy increases both shade and evaporation, cooling our neighborhoods. These systems do use water, however, which is an increasingly important resource, and can be a problem in very cold weather, where freezing may occur, or very humid weather, where evaporation is slowed. For one recent project, we had to weigh evaporative cooling and the risk of downwind fogging versus once-through cooling and the potential to change the temperature in a nearby sensitive lake. Ultimately, engineers have to decide for ourselves what works best for a particular project. But even if it's not appropriate everywhere, the potential benefit of evaporative cooling should not be missed.